Hi Chem students, welcome to today's lesson over neutralization and titrations. Please have out your notes, something to write with, and a calculator. Okay, we're going to start with discussing neutralization reactions. This is actually review. Neutralization reactions are double replacement reactions between an acid and a base. So an acid and a base are your reactants, and salt and water are your products. Let's look at number one. So in number one, we've got hydrochloric acid reacting with sodium hydroxide. And because this is a double replacement reaction, I like to use the box method. And we're cutting apart hydrogen from chlorine and sodium from hydroxide and boxing them together. So my products are sodium chloride and water. Remember your oxidation numbers on your periodic table: +1, +2, +3, -3, -2, -1, and 0. So because sodium is +1 and chlorine is -1, they cancel to form sodium chloride. And then we have hydrogen with the +1 and hydroxide with a -1 on the back of your periodic table, forming water. Okay, and then lastly, you want to balance these, and these are balanced. It's just a 1-to-1 ratio. Okay, let's look at number two. So we've got sulfuric acid, potassium hydroxide. Again, I'm going to use the box to separate the hydrogens and hydroxides. So I've got potassium with sulfate. Potassium is a +1. Sulfate is on the back of your periodic table. It is a -2. So when you crisscross, you get K2SO4, and of course, water is produced as well. This time we do have to balance by adding a couple of coefficients, a 2 in front of potassium hydroxide and a 2 in front of water. Okay, at this time, if you'll pause the video, try number 3 on your own. When you come back, I'll have the answer for you. Okay, welcome back. I hope you did okay on number 3. Let's see how you did. So again, I always use the box, and I see that I'm going to put together calcium with nitrate. Calcium is a +2, and nitrate is actually a -1 right here on the back of our periodic table. So I get CaNO3 with a 2 outside of the parentheses, and water is formed. So I do need to balance by putting a 2 as a coefficient in front of nitric acid and in front of water. Okay, at this point, we're going to see how neutralization reactions are going to help us in real life with titrations. A titration is a laboratory procedure in which an acid of unknown molarity is mixed with a base of known molarity until neutralization occurs. By measuring the volumes of acid and base necessary for neutralization to occur, the concentration of the unknown can be calculated. This is the purpose of a titration. So our laboratory setup. A burette is used to dispense a base in a precise manner in order to combine it with the acid. So the base goes in the burette here. An indicator such as phenolphthalein, bromethyl blue, or methyl red is a chemical that's used to identify through a color change when neutralization has occurred. Without an indicator, you cannot tell when neutralization has occurred. And the reason being is usually the base in the burette is clear, and so is the acid in our Erlenmeyer flask. When you mix together clear liquids, nothing magical is going to happen. It's not going to change color without an indicator. So you need an indicator that will tell you when neutralization has occurred. It says here, the point at which the acid and base stoichiometry is equal, meaning there's 1 mole of acid for every 1 mole of base, is called the equivalence point. We say that neutralization has occurred here. The point at which the indicator changes color is the end point. It's important that we must choose our indicator so that the end point and equivalence point coincide as closely as possible, meaning the color change happens when the acid and base have neutralized each other. Different combinations of acid and base require different indicators for successful titration. Discussion of how to choose an indicator is beyond the scope of this course. So when we do this in lab, we will choose the indicator for you. It's just important for you to know that the purpose of using one is to show visually when the equivalence point has been reached. Okay, so I was actually able to find a titration simulator online, so I can show you how this works before you do it in lab. So I set my parameters already. I chose a weak acid and a strong base. I filled the burette with base. The acid that I chose was acetic acid and sodium hydroxide for my base, and phenolphthalein is the indicator that I have chosen. So if you look at this apparatus, in the burette is the sodium hydroxide base, and in my Erlenmeyer flask here I have added the acetic acid, and there's this little magnetic stirrer here that is going to constantly be stirring my solutions when I combine them, which is really nice because as you get close to the end point with phenolphthalein, it will turn pink for a second, but you're going to stir it and that's going to go away. You've actually reached the end point when it doesn't go away. So I have pre-prepped this. I've added actually 16.5 milliliters of the base already. So it's close to the end point. Now I'm going to go drop by drop. And you can see when I add a drop, that turns pink for a second and it disappears. This is where you're going to get really frustrated in lab because you're going to want it to stay pink and it's not going to. And you have to be really careful not to over titrate. I'll show you what that looks like in a second. So I'm just going drop by drop. And I am adding one drop and letting it stir because if I go over, that will be bad and it's going to upset me because then I have to stop this and re-record. And I've actually already done that like 5 times. So I'm trying to get this one right. So we're going drop by drop until it finally stays pink. Okay, there we go. Now we have a perfect endpoint being shown here. So when the phenolphthalein turns this super light pink color and it stays pink, you reach your endpoint and that's where neutralization has occurred. And it's tough to get this pretty light pink color, and you'll see that in lab. We'll make it a little competition for kids to get it first. I'm going to go ahead and overdo it just so you can see what going over the endpoint looks like. If I over titrate, this is what happens. I'm going to add a whole bunch. You see how it's fluorescent pink? That's bad. You don't want that. But hopefully this little simulation helped you so that when you get to lab, your technique will be a little bit better. Titration calculations. This formula can be used to solve all titration problems. It will be given to you so it doesn't need to be memorized. NB-MA-VA equals NA-NB-VB. So N stands for coefficients, M is molarity, and V is volume. Now these little subscripts represent whether it belongs to the acid or the base. Okay, let's look at an example. What is the molarity of a hydrochloric acid solution if 55 milliliters neutralize 75 milliliters of a 2 molar sodium hydroxide? Okay, let's label what we know. It's asking what is the molarity of hydrochloric acid? So it's asking what is the molarity of my acid? And I know this is an acid because it starts with hydrogen. If 55 milliliters, so this is the volume of my acid, neutralize 75 milliliters of a 2 molar sodium hydroxide. Hydroxide making it a base, so this is the volume of my base and this is the molarity of my base. Now, before we can do anything, we have to have a balanced neutralization equation. So I know that hydrochloric acid is reacting with sodium hydroxide. This is a double replacement reaction, so I want to use my box in order to separate the ions. So hydrogen is separated from chlorine, sodium from hydroxide, and I'm boxing in the middle. Okay, on the product side, what forms then is sodium chloride. Sodium being +1, chlorine being -1, so they cancel, and water. And what's beautiful about this reaction is these are all 1-to-1 mole ratios, meaning to balance it, you just need coefficients of 1. Okay, so next I'm going to rearrange my equation to solve for MA. So in order to do that, I'm going to look up here at the top, and I want MA by itself. So I'm going to get rid of NB and VA by dividing by them on both sides. And when they cancel, what I get is MA equals NA MB VB over NB VA. So what you have to really be careful with on these equations, they're not hard, it's just algebra, is making sure the little a's and the little b's follow you so you don't mess up and make a silly mistake. Okay, now let's plug in my numbers. Na, that's the coefficient of my acid, it's a 1, times Mb, which is the molarity of my base. I already labeled it in the problem, so it's 2.0, times the volume of my base, which is 75, divided by NB, which is the coefficient of my base, which is a 1. and VA, which is 55. Okay, so now all I have to do is plug this into my calculator. 1 times 2 times 75 divided by 55. And I get, rounding to two significant figures because we always round to the least amount of sig figs, I get 2.7 molar hydrochloric acid. Since it's asking for the molarity of my acid, I know that my unit should be M for molar, and it should be labeled HCl for the acid. Okay, so at this time, I want you to try number 2 on your own. Go ahead and pause the video, and when you come back, I will have an explanation for you. Okay, welcome back. I hope you were able to solve number 2 on your own, but let's go through it together. It says, what is the molarity of calcium hydroxide solution if 20 milliliters neutralize 5 milliliters of a 1 molar nitric acid? So let's go ahead and label what we have in the problem. It says, what is the molarity of calcium hydroxide? So we know this is asking, what is the molarity of my base? It tells us that the volume of the base is 20 milliliters, and that it's neutralized by 5 milliliters of a 1 molar nitric acid. So we know the volume and the molarity of our acid. Next, we need a balanced neutralization equation. So if nitric acid and calcium hydroxide react in a double replacement reaction, this is what we get. Calcium nitrate and water are produced, but then it is necessary for us to balance the equation. So we add coefficients in order to balance. Hopefully you did this correctly. If not, go ahead and do it now. So we know that the 2 is the coefficient for our acid, and the 1 is the coefficient for our base. Now we're going to rearrange our equation to solve for the molarity of our base. So if you did that correctly, you would get molarity of our base equals the coefficient of our base times the molarity of the acid times the volume of the acid divided by the coefficient of the acid times the volume of the base. You plug it in and you should get 0.13 molar calcium hydroxide for your answer. I hope you did this correctly. If you need any help, it's a great time to pause the video and ask your teacher for help. All right, this is it for our titration video. I hope it was helpful. If you need any help, please ask your teacher. Have a great day.